teacher, please, it's an emergency. Quick, I don't remember how to change the fraction 1/5 into a decimal. You've got to help me. Hurry. So that's the really ridiculous, that's the question at the top of the paper, right? So mostly my point is, can we simplify these problems? Okay. As we go, we can fill in the work on the bottom to find out what the funny, hilarious answer is, right? Okay. So here, if we're multiplying like bases, we're asked to remember what we do with the exponents. And they show us that if we're multiplying like bases, what do we do with the exponents? Add. So number 1 is L. So problem number 1 is L. So there's an L there. All right. So then what did you get for number 2? X to the 12th, which is H. So number 2 is H. Multiplying like bases, we add the exponents, but what do we do with the numbers in front? Well, multiply them. It's a multiplication problem, right? So 20x to the 16th. Yes? And what's that? C. So 3 is C. What about 4? When we're dividing like bases, what do we do with the exponents? Subtract. Excellent. X to the 13th, which is, I'm sorry, N? M. So 4 is M. Number 5, multiplying like bases, what do we do with the exponents? Add. What's negative 5 and 2? There's not an x to the negative 3 over here. Why? Can't have a negative exponent, so we move it to the denominator. 1 over x to the 3rd is D. Correct? So 5 is D. Number 6, what do we have? What if we have a power being raised to a power? So we get 49 because that's 7 squared, right? But x to the 8th squared is x to the 16th. Excuse me. So that is S. Is that correct? 6 is S. Number 7. Do I multiply this 3 here and get 12? No. Oh, okay. So order of operations does matter here. We have to square everything first, and then we can multiply by 3. Okay? So I end up with 3 times, what is 4 squared? 16, x to the 16th. So it's now 3 times 16. 48. 48 x to the 16th, which is A. So 7 is A. So I'm pretty sure the first word is calm. I'm pretty sure. Okay. All right, what about 8? So I subtract 14 and 2, right? Why not? You told me a second ago I subtract. Oh, the exponents only, right? What do I do with the 14 and the 2? Divide. So what it asked me to do, right? So 7x to the 16th, where's that? E. So what? That's a crazy E. I'm sorry about that. 8 is E. Okay. What about 9? Subtract. I could do 3 minus 4 and get negative 1 and have to move it to the bottom again. Or I could start where the bigger one is. 4 is bigger than 3, isn't it? So what is 4 minus 3? 1. And I started in the denominator, so leave the answer in the denominator. Is that one there? Yeah, it's W, right? So 9 is W. Oh, there's 2 of them. And then 10. This one's not hard, it's just lots of steps, right? So I gotta cube everything first, and I get x. Oh, I can combine these first, though, can't I? That'll make things a little easier. Get x to the 12th. Excuse me. And get x to the 7th. So x to the 7th to the 3rd is x to the 21 over x squared, which would give me x to the 19th, which is n. So 10 is n. Ooh, there's 2 of those too. That's exciting. Number 11. Simplifying first. Inside. X to the 13th squared. X to the 26th. simplify the denominator as well. X to the 6th, so I end up with x to the 20th, which is O. So 11 is O. 11 is O. So I'm pretty sure the second word is down. You don't think so? Okay, we'll check in a second. X to the 10th plus x to the 10th plus x to the 10th is x to the 30th, right? Because it's like basis, so we add exponents. No. What am I doing? I'm adding. What should I end up with? 3x to the 10th, because there's 3 of them. 3x to the 10th is t. The teacher told the student to calm down. You are 2/10. All right. On which one? Oh, down here? That's a good question. Could it have something to do with this one? If you did 3 to the 8th or something like that? No? Oh, okay. Okay. Yeah, I really don't know. It's probably a... Yeah. That's probably more likely. They just needed another letter. Is there... Well, we didn't use Z either, did we? Or K. Or G, it looks like. There's a K, but we didn't use it down here. Yeah. That's what she means, I think. Okay. So... We're going to go to this worksheet called fraction powers, and I'm starting on the side that number 1 says consider the function y equals 9 to the x. Okay? This is really the meat of our lesson today. All right? This is really the meat of our lesson today. So we need to complete this table first, and we're going to complete it without a calculator because we're not babies. I need you to use your brain for a little bit today. Okay? So probably the first one that you're very confident with is 9 to the first power. Right? What is 9 to the first power? 9. What is 9 to the second power? 81. Could you figure out 9 to the third power? Pretty easy. Maybe not pretty easy. 729. Okay? 729. It's okay. So... Some people know 9 to the 0. Fewer people know 9 to the -1 or 9 to the -2. But I want to help build that knowledge for you. I want to show you something real quick right here. Okay? Normally we go down the table, right? But if there's a pattern going down the table, shouldn't there also be a pattern going up the table? So let's start right here. How do I get from 729 to 81? Divide by 9, right? How do I get from 81 to 9? Divide by 9. So how do you think I would get to the next term in the table? Divide by 9. Do you see that pattern? Okay. What is 9 divided by 9? 1. Most people, when I say what's 9 to the 0 power, what do they tell me? 0 is what they usually tell me. Okay. Can you see why it's not? If we're following the pattern in the table, it's not. Then what is 9 to the -1 if we're following the pattern in the table? 1 over 9, 1/9, because we're dividing by 9, right? Then what is 9 to the -2? 1 over 81. Because remember, dividing by 9 is the same thing as multiplying by a 9th. Okay, so a 9th times a 9th is an 81th. I don't know if that's real. Okay. I really don't know. I don't think it matters, but thank you for asking. Okay, so when we're looking for the pattern like it's asked us to do right here, let's look down the table because that's how we typically read a table. What is the pattern as we go down the table? Multiply by 9. Okay. Now look at this table. This table is a little strange. Just like most of us, right? We know 9 to the first power. Excuse me, 9 to the first power is 9. I know 9 to the second power is 81. And I know 9 to the third power is 729, right? Because we just, first of all, filled that in on the table over here. How in the world would I get 9 to the 1.5 power if I'm asking you not to use your calculator? Okay? We're going to leave this for a second and come back in just a minute, because in order to figure out what 1.5, 9 to the 1.5 power is, we really have to know what 9 to the half is. 9 to the 0.5 is first, don't we? Okay? So let's consider 9 to the 1/2. What does an exponent of 1/2 mean? Well, compute this equation with the rules that we just used. 9 to the 1/2 times 9 to the 1/2. For multiplying like bases, what do we do with the exponents? Add them. So that is 9 to the first, or 1th. Pretty sure it's first. Just saying. But what if we let x equal 9 to the 1/2? So substitute x anytime there's a 9 to the 1/2. So we end up with x times x equals 9. Is it okay if I just write 9 instead of 9 to the 1th? First? Sorry. Okay. Well, x times x equals 9 is really the same as x squared equals 9. Right? Yes? How would I solve for x? Square root. That's the most logical answer, right? If I square root both sides, I get x equals the square root of 9, except we know that. It's 3, isn't it? Okay? So, I know it says use a calculator. Let's not. And be rebellious. 4 to the 1/2. What does to the 1/2 mean again? What did we just figure out? Square root. So what's 4 to the 1/2? 2. What's 25 to the 1/2? 5. 256? Anybody know off the top of their head? Check it in your calculator real quick. I don't mind you checking it. That's fine. We can just be kind of rebellious. How about that? 16. Okay. What about 42.25 to the 1/2 power? You guys know that off the top of your head? Go ahead and check it in your calculator. 6 point something. It's 6.5. Okay. What about 3 to the 0.5 power? Wait. Why did I just change from 1/2 to 0.5? Did you even notice that we did that? Okay, some of you did and some of you didn't, because it's so ingrained in your head that 1/2 and 0.5 are the same. It's just like no big deal, right? If you noticed it, that's great. If you didn't notice it, that's also great. It's also okay, all right? So what is 3 to the 0.5 power? 1 point. Give me 5. 205? Is that exactly what your calculator says it is? So is that exactly what the square root of 3 is? Why not? Does anyone else's calculator say the same thing as that? Because, and the reason why I ask is because earlier the calculators we used last period, they said 1.73205. Done. Okay? So we had to have just a real quick conversation about that. What was happening? Calculators rounding, right? Probably on their settings they have it on float 5, probably. Okay, for the calculator round at 5 decimal places. So if you have your calculator set up like that, which is perfectly fine, please understand that it is rounding for you when you have it on float 5. Okay? Before, if you've already done it, you shush. Okay? Before we put this in the calculator, can you tell me approximately what the answer is going to be? Somewhere around 9? Why in the world would you say somewhere around 9? Oh, because 81 to the 1/2 would be 9. So is this answer going to be more or less than 9? Should be a little bit less than 9. Go ahead and do it. Tell me what the answer is. Give me 5. Isn't that about 9? Yeah. Okay, now without a calculator, for real, evaluate 100 to the 1/2. 58. That's close. It's really 10, right? What common mathematical process yields the same result as using an exponent of 1/2? Square root. Okay? Now, somebody said radical, and we have to talk about this. Okay? Because we called this sign, and I was very specific about it. I said, this is not called a square root. This is called a radical, right? That's what the name of the sign is. We use it to take square roots, right? But this sign is called a radical. Well, guess what? We have to write square root here. We can't just write radical. First of all, that's the name of the sign, but more specifically, we are taking the square root. Not any other root, but the square root. Good observation, good talking point. Okay? Any questions about that? Okay, I know this is still blank. We're going to come back to it. Okay? I know it's still blank. We're going to come back to it. Go to number 2. Consider the function y equals 8 to the x power. How is this different? Okay, it's not a 9, right? Now it's an 8. You're okay with that? So complete the table. Let's do like we did before. We know probably 8 to the first power is 8. 8 to the second power is 64. What's 8 to the third power? Is it 512? I hope. I already wrote it down. Yes? Did you check my math? Okay. So then let's go backwards. Think about this logically. If I from here to here divide by 8, from here to here divide by 8, from here to here, can I divide by 8 and get 1? Does it make sense that 8 to the 0 power is 1? Okay. 1 divided by 8 would be 8 to the negative 1 power. Okay? And then divide by 8 one more time and I get 8 to the 1 over 64. Okay? Remember with negative exponents, we don't like those, do we? All right? So just a real quick review of some stuff we talked about earlier in the year. 8 to the negative 2 power would equal 1 over 8 squared, which is 64, right? 1 over 64. You okay with that? Just another connection. Okay? What's the pattern going down the table? This way. Multiply by 8. Okay? I know this is here. I know you want to fill it in. We're going to wait. Okay? We're going to wait. Before being able to compute 4/3 or 10/3, which is what they want to do here, we need to consider 8 to the 1/2 power. What is 8 to the 1/2? Thank you. 1/3. 8 to the 1/3. What does an exponent of 1/3 mean? Well, complete this equation. 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3 is really 8 to the 1. Right? Multiplying like bases, we add the exponents. A third plus a third plus a third is 1. Let's let x equal 8 to the 1/3. So we have x times x times x equals 8, or x cubed equals 8. So what we have to figure out is what times itself equals 8, right? That's what x to the third means, right? So what times itself equals 8? Well, we know it's 2. How do we write that middle step? Remember on this side we wrote the square root of 9? A cube root, right? Does a cube root kind of make sense? Okay, watch how we do it. Cube root with the little baby 3 in front. It's a radical with a little baby 3 in front. Now, for the record, we don't say a radical with a little baby 3 in front. We say a cube root, okay? Just trying to make sure we understand each other and the language going on. Okay? We say the cube root of 8. Now, if you want to use a calculator for these, you can. If you can do them in your head, that's fine. I'm going to keep going. Okay? So if you want to watch it to finish it, that's fine. Okay? Cube root of 64 is 4. The cube root of 216 is 6. The cube root of 500 is something, and I don't have my calculator handy, so we'll pretend you guys can figure that out by yourself. Without a calculator, we're going to evaluate 125 to the 1/3, and that is 5. Okay? What common mathematical process yields the same result? That is a cube root. Okay? Now the thing that's interesting... Hey, somebody hand me that calculator, please. Right there. The thing that's interesting here, I'm going to just do 500 real quick so that it's done. 500 raised to the 1/3 power. See, 7.93701. 7.93701. And see, that's approximately equal. You even know it's not going to be a nice whole number because even the paper tells you it's going to be approximately equal. Okay? So the thing that's interesting up here is when we go to complete this table, we know that 3 now is 512 because we filled that in on this other table over here, right here. But if we have 8 raised to the 4/3 power, we're going to get 16. And that's surprising to a lot of people because they think if it's raised to a fractional power, we should get a decimal. Okay? And we don't in this case. 8 raised to the 5/3 power also seems like it should be fractional number or decimal number. And we get 32. 8 raised to the 7/3 power. Again, a nice integer number. Okay? And 8 raised to the 8/3 power gives me 256. Okay? So the pattern going down this table is this time multiply by 2. Okay? Every term you multiply by 2 to get to the next one. Okay? Going back to the front side right here, if we're doing 9 raised to the 1.5 power, we get 27. 9 raised to the 2.5 power, we get 243. It's not ugly decimals like you may think that it happens or that it will be. Notice that as you travel down this table, we're multiplying by 3. Okay? Because each half power is the square root of what you were originally multiplying. Because each 1/3 power here, it's multiplying by the cube root of what you were originally multiplying by. Okay? Another way you can think about it is we're going to really concentrate on this tomorrow when we do the rules. But this would look like 8 to the 4/3 power. We talked already about the fact that the bottom is the root. This is the cube root. What's the cube root of 8? The cube root of 8 is 2. And 2 to the 4th power, that's the power, is 16. So we could actually have done this just in our head without even having to use a calculator if we know the trick that the bottom is the root and the top is the power. Okay? I hope you have a great day. Peace.